Today we're going to talk about what you should do if you're dividing and you have a decimal in your divisor. Now, quick refresher on vocab. Your divisor, if you're looking in fraction form, is your denominator. It's the number outside your division house. It's the second number in your division sentence. A divisor represents the size of your groups or how many groups you're making. So when it's a whole number, like our divisor is 3, it's pretty easy to think about, okay, I have 12 items and I'm splitting them up either into groups of 3 or I'm making 3 groups. Either way, you can find your quotient. It gets a little bit harder to think about when we have groups of 3/10. Okay, I have 12 items and I want to split them up into groups the size of 3/10. Well, that's not even a whole number, so what are we going to do about that? So let's take that problem. 12 divided by 3/10. My favorite way to deal with fractions, or to deal with decimal problems where we're dividing and there's a decimal in my divisor, is to think about them like fractions. So what we want to do is we want to make our divisor a whole number. Well, how can we do that? We can't just change one part of my problem. So we're going to change both parts of the problem. If you think back to what you've learned about fractions, we can multiply by another fraction. And if I multiply by a fraction that has the same numerator and denominator, that is essentially multiplying by 1. I like to call it a fancy 1 because it looks a little different than just writing the number 1. But 10 divided by 10 is 1. Any number divided by itself is 1. So we're not changing the value of our original division problem, we're just going to change the way it looks. So if I do that multiplication, I'm going to say 12 times 10 is 120, because remember when you're multiplying fractions by fractions, you multiply numerator times numerator, denominator times denominator. I'm going to multiply 3/10 times 10, and that gives me 3 wholes. Now that's what I want, because now I can do some division when I have a whole number as my divisor. Notice that I'm keeping my 3 instead of 3/10, and my changed 120 instead of 12. The nice thing about this is while I've changed the way it looks, it's not going to change my quotient, my answer. So I can just go ahead and do my division. Well, how many groups of 3 can I make if I have 1? None. Subtract, bring down. How many groups of 3 can I make if I have 12? 4 groups. Subtract, bring down. How many groups of 3 can I make if I have 0? Don't just stop because you think you've got a 0 as your remainder. I can make 0 groups. Now that I have nothing else to bring down and I have a remainder of 0, now I can stop and say that 12 divided by 3/10 is 40. Let's try this one. You might have previously seen a strategy either in this form or in long division form where people are scooping or jumping, and this is a trick that we can eventually use, but it's not one that I like to teach right away because it's not teaching you why we do that. So I always like to turn them into fraction problems first. My dividend, my divisor. Notice here that we have 2 different place values. Down here we're just talking about tenths. In our numerator we're talking about hundreds. I am okay. I already know how to divide if there's a decimal in my dividend. So I don't need to make my dividend a whole number. In fact, if I do, it's just going to make my divisor a larger number, and while it's still going to give me the same answer, it's just going to be a little more work. So I only am concerned with making my divisor a whole number. So I'm going to take a look. I see tenths. So I'm going to multiply by a fancy one of 10 for the tenths over 10. What's that going to give me? That's going to give me 94 and 6/10. Again, I'm not really worried about it if I have a decimal in my dividend. And it's going to give me 22 and 0/10, but I don't need to write that. Just 22 wholes. Now I can set it up in my long division problem. And I can start solving. Well, if I have 9, I can't make any groups of 22, so that's 0. Subtract, bring down. If I have 94, how many groups of 22 can I make? Well, I'm going to count 22, 44, 66, 88. Oh, that's it. 4 groups. 88. I'm going to subtract. I'm going to bring down. Now, should I bring that decimal down? Nope. I don't bring my decimals down, but I do raise them to the roof of my house. Right there. And now I'm going to say how many groups of 22 can I make if I have 66? Well, 22, 44, 66, that's 3 groups. 3 times 22 is 66. Subtract, 0 remainder, nothing else in my dividend to bring down. So I am all set. And I can say that my original problem, which was 9 and 46/100 divided by 2 and 2/10, has a quotient of 4 and 3/10. You can also say that 94 and 6/10 divided by 22 has a quotient of 4 and 3/10. Both of those are true. This was my original problem. So if I was going to rewrite my whole number sentence, that's what I'd go with. All right, let's do our very last example here. So I want to show you where, again, that scooping method is coming from. So if I already have it set up in my long division, that's great. I still do take it back out and put it in fraction form. That's a 5. And then multiply by my power of 10. So here I have 3 and 25/100 as my denominator or my divisor. So I'm going to multiply by a fancy one of 100/100 because that's going to make my denominator or my divisor a whole number. So that would give me 2075 divided by 325. And this might be what you're used to seeing, 1, 2, 1, 2. What those scoops really represent are multiplying by a factor of 100/100. So you can't have just some scoops in your divisor. You have to have the same number of them in your dividend as well. And frankly, I would prefer it in my class if you modeled your work in fraction form and what fraction of base 10 over base 10 that you're multiplying it by. So then you would actually do the division. I'm going to do the division here because it's going to look a little bit different, and I want to talk about how we can write our quotient. So here you can see I started my division, and now I'm at a point where I have a remainder and I don't have any other digits in my dividend to bring down. So I'm going to say that 2075 is the same as 2075 and 0/100. So I'm giving myself more zeros to bring down. I'm immediately going to take that decimal point, raise it to the roof, put it right above because I want to have it in my quotient too. So then I can keep bringing some zeros down. All right, here's my quotient, and you can see it's kind of long. So my quotient would be 6 and 3,846 10,000s, but what you don't know is that it doesn't have a remainder. It keeps going. So that brings us to our last thing to learn today, 2 new vocab words. Okay, I was wrong. It's 3 vocab words. So our first 2 are terminating decimal. Terminating means stop, like a stop sign. It means that the decimal ends. So an example of that would be if your quotient is 7 and 25/100. Yes, we could keep adding zeros to that forevermore, but our answer ends and there's nothing else to write in our decimal. What I just had was a quotient that was a non-terminating decimal. So it was going on forever and ever in kind of a random pattern. A non-terminating decimal would be one that never stops. You see I put this little ... right there. That means it goes on and on and on. And it doesn't necessarily follow a pattern. So we don't see a pattern here in these numbers, which is different from our last vocab word, which is repeating decimal. Repeating decimal might look like this. The same number or the same pattern of numbers repeat and go on and on and on. Now, instead of writing those out and filling the entire page, with a repeating decimal, you can signify that with a line. So I could rewrite this as 17 and 6/10 repeating. The little bar at the top means this number continues and I don't feel like writing it for the rest of my life, but you should know that it goes on and it's not the same as 6/10. Same with a pattern of repeating numbers. So instead of writing 1 4 1 4 1 4 1 4, I can put the bar over both the 1 and the 4, and that tells me that the answer is 17 and 14 14 14 14 14 14 forever and ever and ever. But you don't want to spend your time for the rest of eternity writing 14 14 14 14 14. So we use the repeating bar instead.